Perimeter defenses. This is the physical security stuff. So a 3-foot fence, anybody can just climb over it, so it's a deterrent. It might discourage people that aren't trying very hard, but 8 foot is preventive. 8 foot with barbed wire on top. The intention of that is most people are going to find it impossible to get over it, so it actually prevent people from going in there. There's ornamental gates, class 1, and then it goes all the way to crash gates, stop 4, class 4. That will stop a car. So bollards are these posts that stick out of the ground. You see them everywhere, especially since the Oklahoma City bombing, which made it painfully obvious to everyone in America that you really do not want to let someone drive a truck up near your building and like stop it there. So they put up these posts to stop people from driving in areas near buildings. Then lights, of course, are good. That's why most businesses leave lights on all the time as a deterrent or a detective measure, so they can pick up what's going on in the cameras, and hopefully criminals will be less inclined to break in because they're going to be visible. Closed circuit television is a detective control. You could use infrared cameras. It used to be done with analog devices. These days it's almost all done with digital devices, of course. And as you may have noticed if you watch cop shows, these things tend to be really grainy and blurry and black and white and hard to read. Not that great, but anyway, there's issues. Now a bunch of people have them at home at their front doorbell. They get a Ring doorbell and it's photographing everybody that comes to their front door, which is probably a good trick for security. And then locks, of course. Key locks have maybe 5 levels and 5 pins, so there's a combination here, and these pins have to be lifted to just the right pattern of height so that there's 2 pins here and the gap between them is here. So when you get them all to the right height, the lock will turn. If any one of them is at the wrong height, it will hold the lock so it doesn't turn. This is how pin tumbler locks work, which is the most common kind of lock we're using. And you can pick it. With a tool, you can just go in and you put a tension tool in to try to turn the lock with a little bit of force, and then you reach in and lift the pins until it catches, because it turns just a little bit, and so you can open the pins one by one and open the lock. Because there's some tolerance, these pins are not perfectly tight in the holes, there's some play. And we'll be doing lock picking here, I should point out. On October 29, there's an extra credit lockpicking event, so if you want to come to this room physically, we'll pick locks here on October 29, Tuesday. Anybody is welcome to do that for extra credit in any of my classes, and it's a good skill to have. If you haven't picked locks, you should learn how to pick locks. It is, the main message is that these locks are much, much less secure than people think they are. Anybody who wants to get in your front door by picking the lock can do so very easily. So that is the thing to be aware of. Bump keys are the even easier way. What you do is, instead of lifting the pins one by one, you just take a key and you shave it down to the bottom all the way across, so all the pins are at the bottom. Then you just tap it with a screwdriver, tap, 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 and get until it randomly lines up to the right position. Yes, Wednesday night is also extra credit. Good point. There's an event coming up. This is also extra credit. If you attend this thing, where we're going to do something with Kali Linux and I think AI. So yeah, tune into this. You don't need to come physically for this one either. You can tune in remotely or come physically Wednesday night. Good. Thank you for reminding me. All right, so that's bump keys. They're master keys. Industrial locks are sold this, where there's a master key that can open every lock in a zone, and you can have a core key that is a way to rapidly rekey interchangeable core locks. And then there's these combination locks that look like they have a lot of combinations, but they don't really. There's just a few shapes inside there that are predictable, and so there are ways to predict by pulling on this and feeling the points where it catches. You can predict what the combination is. And you also, I've heard, you can just hit them with a hammer and knock it loose and get it open. So these are not terribly secure either, any more than normal key lock. And button and keypad locks also tend to be weak, because after time the keys wear down, so you can see which keys people are pressing, so you don't really have to try all combinations. Anyway, smart card that contains a computer chip, like modern credit cards do. Now that we have chip, so it can be contact or contactless, as we've all using it to buy products now. A magstripe card has data stored on a stripe of magnetic material. That's the older system and generally less secure. And this is a U.S. Department of Defense Common Access Card, smart card. And just like a modern credit card, it's got this little chip here, which makes contact with a reader when you plug it in, and therefore basically contains a cryptographic key, like a digital certificate essentially is what it contains. All right, so you can follow a person through a secure door after they open it. So to prevent people from doing this, you can forbid it in policy, have security awareness training, or you can have these turnstiles where there's little pieces of metal turning, and the goal of that is to make sure only one person goes through per authorization. And the best thing is a man trap, where you have something like an elevator, where you open one door and you have to close this door and be trapped inside, and then verify your identity to open the other door. So if your identification is not accepted, there you are trapped, and they can just call the cops and say, we got this guy locked up, come arrest him. You know, that's the more secure way to do this. But one thing about them all is if the building's on fire or something, they have to open up to let people out, and that's often the weakness. All you have to do is trick it into thinking it's time to open. They often do this with a motion sensor inside the door, so you can do things. Stephen Olam has a lot of demonstrations of this. He's a famous hacker for physical security. You can do things like poke a stick in through the gap in a bank door and wave it around, and it'll think there's somebody trying to escape and open. He did one where he just took a gulp of whiskey and spit it through the gap, and that created a sort of moving fog inside and made the door open. You know, that's the problem. You don't want to have people trapped if the building's on fire, and that's a weak spot in your physical security. So identify forbidden objects. This would be nice. The problem is there's a lot of small devices like SD cards and thumb drives are very hard to detect. Motion detectors typically work by sending out a signal and measuring the reflected signal, or they just send a beam across a monitored space to see if the beam is broken. And the problem is it's pretty easy to fool these. You can have these magnetic door and window alarms where there's little magnets on the window so it notices whether it's open or not. Basically, they have them here at the college in some of the rooms. Just make sure you have to close all the windows before you can leave, or the alarm won't set. And doors, of course, you have to have the hinges inside, or people can take the pins out of the hinges and open the door, or otherwise protect them. They should be covered with metal. And I mentioned you can poke things through the gap in the door to make it feel like there's motion on the inside. That works on some doors at the college too. We tried it. Of course, you can just smash the glass with a brick. That's an obvious one, unless you pay to get stronger glass. Bulletproof glass like you have in your, or glass with a wire mesh or security film, or plastic that's more shatter resistant. And your walls, in offices that are finished, you have the fluorescent lights, and then you have a fake ceiling there just for decoration, and there's a gap above that that carries air, so people can just push the ceiling tiles up and climb over the wall into the next cubicle and stuff. So your walls should go slab to slab to avoid that. And sheetrock, which is what most walls are, is not very strong. You'd easily cut it. So you'd have to have your walls be something stronger if you actually want your walls to stop somebody from breaking through. Guards, of course, are useful. If you have professional guards with advanced training, that's nice, but most people don't want to pay that much. They get these mall cops who really don't have all that much training, all that much skill, and all they do is observe and report. You have to make sure they understand what they should do. People often try and trick them with social engineering. Dogs are quite valuable. Most homes protected by dogs are pretty safe. Most crooks, they hear a dog barking, they'll just go rob somebody else. It's far too much bother to deal with the dog. Of course, if you have them at a business, they might bite your legitimate customers and stuff, and the dogs might kill those people, and then you might have a legal issue. Right, and you should have visitor badges to record when visitors are wandering around so people know not to let them see confidential information, but they might be saving and reusing the badges, so you should have something like a different badge color for each day or something, so people can't reuse expired visitor badges. All right, let's try another Kahoot, which is here. Someone got stuck on a roof. Managed to open a locked door with a clipper card. Yep, that's right. Credit cards can open doors if they don't have the right kind of shape of the piston. Yep. Defeating physical security is an important part of pen testers, and a lot of talks about it at security conferences. deviant all and wrote a book on lock picking. And then when he gave a guest lecture in my class, he said, I don't even bother picking locks anymore because it's easy to just reach over the top with like a coat hanger and hit the crash bar. Or he finds these little gadgets. He found a thing with he made a thing with wire and rubber bands. He can reach around and take the little chain off a hotel room door. And he said, just reaching around with gadgets seems to be more effective than picking the lock. So, the physical security of most doors and locks is a lot less than people think it is. It's not really that hard to get through them. Of course, the same thing's true of the digital security of your computer. A pen tester could get in. All they have to do is write a convincing phishing email that'll get through 90% of the time. All right, so which one of these is a deterrent? Three-foot fence. It just discourages attackers. It doesn't actually prevent anything. All right, if you shave your key down to the lowest positions, then what have you got? Wow, the time is too long on these. A bump key, all right. Good. How about a smart card? That's ICC is a version of smart card used by the military. Smart cards are not mag stripes. Mag stripes are too dumb. Smart cards have a chip in them that has more intelligence than a mag stripe. All right, which one can use Doppler radar? Ultrasound. They send out pings like sonar and detect if the reflected pattern shows somebody moving. Right. More of this. We got time. Good. All right. So site selection. This is choosing where you put your buildings. So hills, valleys, and trees might be an issue. If trees are near your entrance, then people can sneak in there and such. So you can use bulldozers and landscape them. You can consider the neighborhood. Is there a lot of crime? Are the utilities reliable in this part of town? You typically do not mark your data center. There's no reason for customers to be going there, and you don't really want everybody knowing you've got valuable computers in there. It would be better to just leave it unmarked. If you're sharing tenancy or adjacent buildings, then the problem is the other people might have low security and let people wander around, and that would be used to break into your building, and the wireless networks might overlap, so that's an issue. Your wiring closet should be secured. Boy, I've so many times gone to hotels and companies and conventions and gone past and just see a closet there full of switches and routers and even servers. And I'm thinking, man, I could just pull some plugs and screw this thing up. Those things should be secured, of course. There's a shared DMARC is the location where the internet service provider's responsibility ends. If you buy internet service, they don't deliver it all the way to your end device. They deliver it to a point in your building. They say, okay, your fiber optic goes here. This is the DMARC. We provide service to here. It is your job to cable it from this point on. That's the thing. And your server rooms, of course, require physical access controls, so people can't wander in there without being authorized, and they require environmental controls so it doesn't get too damp or too dry or too hot in there. So you have to store your media offline. Your backups and disaster recovery copies of your data have to be offline because, of course, your whole building could burn down. So you have to get them off-site. And they have to not be connected to the internet, so they aren't going to get wiped out in a ransomware attack. So, you want these things out of there, so you're going to have to store backup tapes or hard drives or something somewhere, or pay for a cloud service like Iron Mountain that will back it up for you, or Google Drives or something. All right. So, in a defense in-depth strategy, an attacker might have physical access to a device with sensitive information, so to give it further defenses, you use asset tracking to identify your devices so you can tell if one is missing. And you can use port controls to restrict the physical ports people can plug in so people can't carry a laptop in and plug into one of those ports and get on your network. And then, of course, environmental controls. The electricity can fail in various ways, and this is bad for electrical devices like servers. So you protect it with surge protectors to stop spikes from like lightning hitting the line. UPSs are much better. They actually have a battery, so they can provide power for some temporary period of time, like 5 to 30 minutes or something. It's not intended that you can keep working through that. It's just intended to be enough time so you can gracefully shut down your servers. Or enough time so you can start your generator. And then you're ready to go as long as you have fuel for the generator, and this is how you'd survive a long power outage if you're a business that must stay up, like a hospital, where the power goes out, but you have people doing surgery and they have computer-controlled devices and lights and everything for their anesthesia and such, and it's really not acceptable to turn it off in the middle of that, so you have a UPS and a generator so you can keep uninterrupted power for essential services. Of course, that all costs money, and it also means you're going to have a tank of fuel, which is another kind of risk, near your building, but that's what you have to do if you need to have uninterrupted electricity. There's electromagnetic interference. Signals from one wire will emit radio that is picked up by the other wire like an antenna, so it leaks. Unshielded twisted pair is the most susceptible to electromagnetic interference. Shielded twisted pair, or coaxial, is less susceptible because it has a layer of foil on the outside which shields the wires inside from most of the radio coming in from the outside. And fiber optic is the most immune at all. External electromagnetic will have no effect on fiber optic. It's just a piece of glass with pulses of infrared light through it. Nothing in there picks up radio signals. There is no actual conductor for electricity. So you got positive pressure typically. You make your building at positive pressure so that things like dirt and dust and water are ejected. You run fans to extra pressure. Your data center should have humidity near 50% and temperature near 70 degrees. Not warmer or colder, and not more or less humid. If it's too humid, then the equipment corrodes, and if it's too dry, then you get static electricity when people go and touch things. So these are the recommended regions. That's static electricity, yeah. And you can also have people wearing wrist straps and grounding circuits to help prevent that. When you're working on devices, you don't want static electricity hurting them. Airborne contaminants are bad. You don't want dust impeding the fans. You don't want other contaminants causing corrosion. So you don't want the air to be too dirty. So heat detectors are thermometers, sometimes just like wax that melts or something. Your smoke detectors use ionization or photoelectric detection of smoke. As you are familiar at home, if your kitchen fire alarm will go off if you burn the popcorn. Then some of them detect the light from flame detectors is another way to do it. So you have to have evacuation routes and procedures. Somebody makes sure that all your people leave the building and they meet somewhere to make sure they all get out. And of course, you have to have some facility for handicapped people in wheelchairs and stuff. If you can't use the elevator, you need to have systems. I know at this college, they've got special chairs and all the stairwells and stuff intended to help those people get out. And you got warning systems to warn people if something bad happens. There ought to be some way of broadcasting that there is something bad happening, like a riot outside or dangerous, like a tornado or something, so you can tell everybody that they shouldn't just walk outside, but they should go hide in the basement or something. Then you got your fire extinguishers. A fire extinguisher is just water for putting out wood. K is for kitchen fires, like oil. And the most important for us is C, electrical equipment. There's most, like a server room. C is special chemicals to put out a fire on energized electrical equipment without shorting it out and damaging it. So you're either trying to reduce the temperature, the oxygen, the fuel, or interfere with the chemical reaction. That's what they do. So there you go. Water, soda, acid, just water is good for paper or wood, but it's not considered good for electrical equipment because it'll short it out. Soda acid is what most of them are, baking soda and acid just to make foamy stuff. Dry powder and wet chemical used for things like flammable metals, which is pretty exotic, like sodium. Kitchen fires, a wet chemical. Deal with the oil. So CO2 will put out a fire, but it will also kill people that are in the room because you have to displace all the oxygen, so that's dangerous. Halon is considered better. It suppresses the fire without suffocating the people. The problem is halon turned out to be an ozone destroyer, was a bad pollutant to release into the environment, so there are new, better chemicals used, FM200, Fe13, or Inrigen, which have the property of putting out the fire without requiring you to displace all the oxygen so it doesn't kill the people, and they also don't destroy the ozone layer. And you can have a countdown timer warning people before you deploy anything so they get a chance to evacuate, and they also get a chance to cancel it if it's a false alarm. And you can have sprinkler systems of various kinds, a wet pipe where the water in the pipe and it's just going to have heat, like open the sprinkler head, or a dry pipe, or a deluge with a large flow of water, or a pre-action that requires 2 triggers because the water is going to damage your things and you really don't want to do it unnecessarily. This sort of thing, various versions of sprinkler systems. Okay, another aspect of physical security. Let's take a look at 3J. All right, so where does the ISP's responsibility end? Called the demarcation point, from a portion that the ISP provides and the portion that the customer has to provide. Which one is important for disaster recovery? Offline backups. Yep. All right. You got to have backups someplace in case of disaster, like the building burning down. All right. Which cable is most susceptible to EMI? Yep. The most common and cheapest, UTP, unshielded twisted pair. This is the most flexible and the cheapest and the most common, but coax is protected by a layer of a sheath of conductor, and so is shielded twisted pair. They're not very susceptible to electromagnetic interference. All right, which fire extinguisher is just water? Somebody didn't answer. My time is set too long. I'll have to fix it, but can't fix it now. All right, that's type A, although it's usually soda acid, but it could be just water. All right. All right, and which countermeasure prevents EMI? This one's only 20 seconds. That's ruined. How can they be different? I'll have to look at it. I didn't know you could set a different time for each question. Anyway, fiber optics really prevents EMI. Electromagnetic interference will not mess with the signal because it's not using electricity. All right. Good. So, I'm going to stop that recording.